short video about geometry terms. Get ready to learn!
Midpoint. Alright, so the midpoint evenly bisects one line. It's going to be at the halfway point. Our real world example is when you're occurring the tip off in a basketball game, and the basketball is usually placed right in the middle, and the ref will hold it up, and boom, that's your midpoint. Alright, here's a little picture of our midpoint formula, and alright, so similar triangles is when two triangles have the same shape but are different sizes. Here we see a perfect example of that, where you can get a small sandwich or a large sandwich, and they have equal ratios, like we see 3 to 6, 4 to 8, and 5 to 10, because 3 is half of 6, so that's going to be our ratio for that. And
okay, so now we have corresponding angles. These are two angles that are in the same position but are located at a different intersection than the other. So like in this parking spot example, 6 and 1 would be corresponding angles because they equal the same measure. Okay, so now we have a linear pair. A linear pair is a pair of two angles that add up to 180 degrees. So for our example, therefore they're making them supplementary angles. Our example is when you have a pizza and you cut it in half, these two 90-degree angles will equal 180 degrees. Hey Zoe, catch the whoa!
woo! Thanks for the whoa. Alright, next is congruent triangles. In order for two triangles to be congruent, their corresponding sides and corresponding angles have to be equal to each other. So our example of this is on the kite, the corresponding angles and sides on the red triangle to the yellow have to be equal. Same goes for the blue and green. Thanks.
For our next geometry term, we have supplementary angles. These are two angles that add up to 180 degrees and are otherwise known as a linear pair. Our example for this is when the clock strikes 6 o'clock. These two angles are supplementary because they both add up to 180 degrees.
Coplanar points are when three or more points lie on the same plane together. Our real world example is going to be 4 puppies laying on the mat tussling around with each other. So this is a good example of coplanar points because all of the points, or puppies, are on the same plane together, which is a rug. But this is an example of non-coplanar points because one of the puppies is not on the rug. And peace.
Shaka! Okay, so for our next geometry term, we have congruent angles. They are two angles that are equal to each other, and our real life example could be the railroad crossing side. These two angles would be congruent to each other, that means equal.
Angle of elevation. So this is the angle that's going to form between eyesight level and looking up. And for our real world example, we have this old man looking up at the tree, and this is the triangle that's going to form that is used in common geometry equations.
Boom! Next we have congruent segments. These are two segments that have the same length. Our example for this are two opposite sides of a building's wall.
Spots off.
Alright, collinear points. So this is points that lie on the same line, and for our real world example, the edge of the cafeteria is acting as the line, and the children eating at the lunch table are acting as the points. And there you have
That is a quadrilateral with exactly one pair of parallel sides. An example of this is the roof on a house, as you can see here.
Alright, vertical angles. So these are the non-adjacent angles formed by two intersecting lines, and they have the same angle measure. Our real world example is going to be this four-way traffic stop where the two opposite corners are vertical angles to each other, as well as these two corners.
Woo! Okay, next we have acute angles. This is an angle that measures less than 90 degrees. So our real world example would be one pizza slice from this very lovely pizza. That will equal less than 90 degrees.
Alright, perpendicular. So this is when a line cuts another line into two equal parts, creating a right triangle. Our real world example is going to be this clock right here, and when it is 3 o'clock, the two arms on the clock are going to create a perpendicular triangle that equals 90 degrees.
Boom! Next we have a radius. This is a line from the center of the circle to the perimeter. Our example for this is a tire. As you can see, the radius is the length from the middle of the tire to the edge of the tire.
You slide on all your nights like this.
Slope. So this is the ratio of vertical change to the horizontal change, and our real world example is going to be right here at this slide where you can find the slope because there's a change in horizontal and there's a change in vertical.
Okay, next we have obtuse angles. This is an angle that equals more than 90 degrees but less than 180 degrees. So for our example for this is a door. And the way the door swings out, if it comes above 90 degrees, then it is an obtuse angle.
Alright, polygon. So this is a shape that is closed in 2D, and our real world example is going to be this stop sign.
Reflexive property. This property is saying that anything is equal to itself. For example, we have x equal x and y is equal to y. And that shows in our balloons because the red, green, and blue balloons are equal to the red, green, and blue balloons over here.
Alright, diameter. So the diameter is the straight chord that stretches across the middle of the circle. It evenly bisects it. And our real world example is going to be the equator on the Earth. And right here you can see that it evenly bisects the Earth into two halves. And when you're trying to find the radius, we know that the diameter is double that.
Boom. For our next thing, we have alternate interior angles. These are two angles that are on the inside of two split parallel lines. For example, on this thing, we have 3 and 5 would be alternate interior angles, and so would 4 and 6.
Parallel planes. So these are flat surfaces that never intersect or meet. Our real world example is going to be how the floor is parallel to the ceiling and they will never meet. Ka-ching!
Now we have skew lines. This is a pair of lines that are not parallel and will never intersect. Our real world example of this is this highway. This line goes above this line, so they're on two separate planes and they will never intersect.
Alright, diagonals of a square. So the diagonal of a square splits the square into two triangles, but there's also the case to where it could be split into 4. In our real world example, this would be when you cut your sandwich diagonally.
Okay, now we have angle bisector. An angle bisector is a line or a segment or a ray that divides an angle into two equal or congruent angles. So for this example, we have this pie. This angle bisector right here would split the pie into two even slices.
Alright, complementary angles. So this is when two angles add up to 90 degrees. Our real world example is on this stopwatch. And yeah.
For our next thing, we have the hypotenuse. This is the long side of a right triangle. So it will be the side of the triangle that is opposite from the 90-degree angle.
Alright, parallel lines. So these are going to be two lines that are across from each other and they will never intersect as they go forward with each other. Our real world example is going to be on the railroad tracks. The two opposite sides from each other are parallel lines.
Now we have segment bisectors. This is a point or a line that splits a line segment into two even PARTS. This line is split by this line as we can see, and boom.
Alright, perpendicular bisector. So this has to form 90 degrees and it bisects one side. Our real world example is going to be this pyramid right here and these sides are bisected right here.
Oh,